In this case, we've got FeS, so which is basically, I could just write it actually. That's iron sulfide. Specifically, it's iron 2 sulfide, and that reacts with oxygen, so it's just molecular oxygen, and it produces Fe₂O₃ and SO2. So that's effectively, I mean, 2, 3, so it's divided by 2. So that's iron 3 oxide, iron 3 oxide, and sulfur dioxide, right? Sulfur dioxide. Yeah, I'm just going to spell it like that. Sulfur dioxide. Okay, so in this case, we've been asked to work out the volume occupied at room temperature and pressure by the sulfur dioxide that's produced from this reaction, and we've been told the mass of the iron sulfide, and we've been told that it reacts with oxygen, with the oxygen being in excess. So how are we going to work out the moles of the or how are we going to work out the volume? Well, we need to first work out the moles of the SO2 produced, right? Because if we can work out the number of moles based on the principle that 1 mole of a given gas at room temperature and pressure specifically will occupy 24 decimeters cubed, we can use the moles information to effectively solve this question, right? To work out the volume occupied, right? But we haven't been given the moles in the question, but we have got the mass of FeS. Now, FeS, as you can see here, is going to be the limiting reagent because oxygen is in excess. And so basically, because of that, based on the mass of FeS, we can work out the moles of SO2, which I'm going to go through the process. So the equation I'm going to need to implement here is going to be the mass is equal to the number of moles multiplied by the molar mass, right? Now, how am I going to actually use this? Well, I'll be using it in the format of making the moles the subject. If we divide both sides by the molar mass, we get number of moles is equal to the mass divided by the molar mass, right? And this is what we're going to be using. So in this case, the number of moles of FeS is going to be equal to 37.64 divided by the molar mass. Now, we have not been told the molar mass in the question, but we have got the formula for the iron sulfide. So using the periodic table, we can work out the molar mass of the FeS, right? So you just put this together, that the MR of FeS, right? And that's going to be equal to, and we've got one of each, right? So as you can see, for Fe, we've got 55.8, and for sulfur, we've got 32.1 in terms of the relative atomic masses. So if we do the arithmetic for that, that's going to be effectively 55.8 times 1, right? Because it occurs once, plus the for the sulfur, it's going to be 32.1 times 1, right? And that is going to give us, if you work that out, you find that comes to 87.9, okay? And that's going to be in the units of grams per mole, okay? Now, from that point, with the 87.9 figure, this would be the molar mass we're going to use here. So just put that in, 87.9. And so if we work this out, this is going to give us what the moles of FeS is going to be, right? So if you do have a go at working that out, I'm going to give my answer to about 7 decimal places in this instance. I'm just going to keep it like, I'll leave the rounding to the end. But this is going to give us 0.428 21 3, and then if we round here, it's going to give us a 9 here. Okay, so that's going to be in moles. Okay, so we've now got the number of moles of FeS, right? But remember, we're trying to figure out the number of moles of the SO2, so like we can use that value to work out the actual volume of gas, the volume occupied by the gas, right? So how are we going to go about that? If we look at a balanced equation, for every effectively what this is telling us is that I'm going to set up a ratio, right? So the number of moles of FeS compared to the number of moles of SO2. Okay. Now, what the equation effectively tells us is that for every 4 moles of FeS, we're going to have 4 moles of SO2, right? Now, if we try and get the left-hand side to 1, right, and we can do that by dividing it by 4. Of course, if we do that, we get 1. But if we're doing that to the left-hand side, we have to do it to the right-hand side. And so effectively, we get 1, 1, right? And what does this mean? Well, what this means is that the number of moles of FeS is equal to the number of moles of SO2, because this simply indicates that there's a 1-to-1 ratio, and based on that, we can say therefore the number of moles of SO2 is equal to what we worked out for FeS. So it's going to be 0.4282139, and that's in moles, right? Now, if we refer back to what the question says, or the information at least that the question gives us regarding the volume occupied by a given 1 mole of any gas specifically at room temperature and pressure, which is the condition of this particular that the SO2 is going to be in this reaction. What we can effectively work out from that is that all we need to do is to multiply our given number of moles. Obviously it's not 1, but if we multiply whatever moles we have by 24, we're going to get the actual volume occupied. So effectively, therefore the volume, right, now is the volume of SO2 is going to be equal to 24 multiplied by our number of moles. So that's going to be 0.4282139, right? And so if you do have a go at working that out, right, what you should find is that you get 10.277 1336, and that's going to be that volume is going to be in decimeters cubed. Okay, now the other thing we need to pay attention to here is the fact that the question does specify give your answer to maximum of 2 decimal places, right? So this is what we're going to do. We're going to round this up to 2 decimal places, which if we do that is going to be equal to 10.2, and then we've got 7, right? So we're going to need to round the 7 up to 8, right? So it's going to be 10.28. I do not need a decimal there. That's not okay. 10.28. I mean, it's not an IP address. 10.28 decimeters cubed. Okay. And that's going to be you can write that as to two decimal places. Okay, so in this particular case, the volume of SO2 is going to be this. It's going to be the 10.28 decimeters cubed to 2 decimal places.